Hello, students. This week we will talk about exception handling. So we are more familiar with errors or what we call bugs because they happen when we are building the software and the Visual Studio will tell us, hey, where there are errors, and these errors will prevent the software from running. If you don't solve these errors, the compiler won't build the code. But the exceptions are harder to detect because it happens during the runtime. So when you're running the software, it may get some unusual behavior. For example, you are expecting an integer and then the user input a string. Then this exception happens. So, so even though it's hard to detect, it's very common, and we need to prevent these from happening, or we need to handle them appropriately. Examples of exception include like here, when you're trying to read from a file, and the file doesn't exist, then it will throw a file not found exception, and this exception is from the system. And when you're trying to read from a database and it doesn't exist, it throws a SQL exception. In other examples, for example, you have an array of 5 elements and then you want to read the 6th element from the array, then it will give you an out of range exception. Or maybe you're trying to do some calculation, division, and then you give the formula 0, and then it will give you an exception of a divide by 0. Okay, so how to prevent these exceptions from happen? There are two ways, two basic ways. One is to do data validation. For example, you can check the type if it's yeah, if you are expecting an integer, and then if the software was giving a string, what should it do? So and so that's called type checking, and you also could check consistency. For example, you could ask the user to input both his name and no, his age and his birth year, and if these two elements contradict with each other, then there's something wrong. And the third one is you can do the range checking in. For example, for the age, it has to be 1 to 100 or 1 to, I guess, 110 the most for age. And for length checking, I guess you can easily give an example like social security number or phone number, and we often use length checking. Okay, and the other way is you can limit user input with radio buttons. With these input options, so they limit the user's input. So generally, the rule is we we cannot assume that the user will follow our rules. You have to assume that they will not read the menu and they will always input incorrectly, and we have to prevent that, or we have to handle these exceptions. It's our duty as a software developer to tell software what to prompt in these kinds of situations. So if you don't handle the exception and letting the exception given by the system to be prompted to the end user, that's not that good for two reasons. First is users may be annoyed as prompted errors are cryptic and does not make much sense to them. And the second is what is more important is the exception contain information and that could be used for hacking into your application. For example, if it's a file not found exception, then the message given by the system could expose hey, which file you used to save the information, save the data. So that's very dangerous, right? Unfortunately, the .NET framework have developed some powerful ways to handle exceptions, and we have the system. Under the system's namespace, there's the exception class that have functionalities to help you manage exceptions. So, next, there are different types of exception in C#, or you call that system exception and application exception. System exception generally refers to those that were predefined by .NET framework and were given by the system. For example, out-of-range exception, format exception, null reference exception. The application exception is referred to all those user-defined custom exceptions. And later we will demonstrate how to create a custom exception. So exception handling means we have to handling those exceptions that occur while we are running the program. And this is usually achieved by 4 keywords: try, catch, throw, and finally. Now let's go to run some code to see how to use these functions. Okay, so this is just a very simple application that adapted from the last lesson. There's a class called customer, and in this main method, we will read in the customer ID and the customer name, and then we will output the customer name. So this runs perfectly. And I could input the customer ID, and then the customer name, and then it will say hello Hinjin, right? So there's no exception, but the user could maybe input nothing, and then it will throw us the exception, the exception, format exception. So the input string was not in the correct format because it's expecting an integer. So next thing we have to do is to address this appropriately. What we could do is to use the try function, and we put the block of code that could possibly go wrong. This block could possibly go wrong, so we input this into the try method. And then if the exception happens, what should it respond? Or we could respond the message, the exception method. For example, this is the exception method. So this is the class, and this create an object EX, and this is the standard way to name the object. Okay, and so this calls the object the property message under the object. And what it will give us is the message. It says what happening with this exception. So now let's try this. Okay, let's rerun this. Now if I import now, okay, it will tell us the input string was not in a correct format, and then close the application. So that's better than the previous version. It tells us what's wrong there. And there are some other properties that is helpful for handling the exception. There is this is the one with EX stack trace. So this one, it will show where the code is wrong. Let's see the difference. So now I input a null, and tells me the string was not in a correct format, and then it tells me where this code went wrong. So this is helpful when we try to refine the code to accommodate the exceptions. So alternatively, some developers might do this. For example, I define this. I define this customer ID here. And then here I give the value, reassign the value to this variable. Okay. And here I can move this one out. So even if this exception happens, then this code will still run. The code will still run. It will not crash the application, and it will still run this try block. It has an exception. It accepts the exception, but it doesn't prompt anything, and then it will still go to the next block of code. So is this good? We try to run this again. So what the consequence of this solution is that it will result in some bad data, right? So this might be even worse than leaving the exception. Not handling the exception. So if you don't handle the exception, the system will kill the process, and it will not result in bad data. And if you don't know how to handle the exception, and then this program will continue to run, and it will result in bad data, and the developer was not informed. So so this is actually a very bad example. So it would be better if we move this back into this try block, and or if you want this program to stop, then you can have a return here. Just simply write a return. Then if there's something wrong here, this application will stop. Okay, but it's okay to move this whole block here. Just put it here. The next question I want to ask is, should we just put a whole try catch block for the entire main method, or should we use a multiple try block for each statement that could have an exception? Like here, this statement and these two statements, this line, these two lines could possibly have exceptions because they get the user's input. So the answer is either way is fine. You could try multiple try blocks for each statement, or you can just use one try block for multiple statement. And you could have different catch block for different types of exceptions. For example, here the exception I could easily get is the format is wrong, right? Format doesn't match. So I could change this exception to a child class called format exception. So with this format exception, it could give us a different message and tell us the specific information that the format is wrong, or it could have more properties than the parent class. For example, here, if I run it again, it will tell me the input string was it not in the correct format. Okay. Yeah, so there are different child classes of the exception class that you could use, such as argument exception,
directory not found exception on these. So, and there could be exceptions other than format exception, right? That we didn't expect, we didn't anticipate. Then we can have multiple catch block. So here I could write another catch block, and this will be a general exception. Any exception happens, and what it will do. Okay. Okay. So this is a multiple catch block, and if the exception happens, would both of these blocks be executed? No, it will only execute the first exception that it catches. Okay.
So far we have used the try and catch. So in what situations do we use the finally block? Here I'll give another example. So in this example, I use the streaming reader, this object, created this object and try to read database, CSV data. And then this exception happens because this file doesn't exist anymore. So then it will go to the catch block, okay, which file couldn't found, tell us. But in this solution, this streamReader.close, this statement will not be executed because the exception happens here, and then it goes to the catch block, right? So this will hold the resource stream reader. Or if it's a database, the database never get closed. That's not good. So in this situation, we could use the finally block. Even there's an exception, the finally block will still be executed. We could move this line here and make sure that this resource will be released. Also write out that, make sure to double check this stream reader is closed. Okay, now let's execute this. Let's refine it a little bit. So only if the stream reader is not now, we close it. Okay, let's do it now. Yeah. So in this way, with the finally block, whether whether there's an exception or not, we make sure the stream reader will be closed and the final block will be executed. So this is often used when you have to use a resource, a database, and you want to make sure the database is closed. So we haven't touched throw yet. When should we use slow? I'll come back to this example with the customer order. Customer input the customer information. Okay, so I could have type checking here if this customer ID is equals 1000. Okay, then I'll throw an exception. This is not the correct format. I could have this throw new exception, and the message could be modified to this is the wrong format. It cannot be cannot be larger than 1000. Okay, so this will manually throw an exception, and then it will be transferred to this block to catch them. So it will be caught at this block. Or you could create a new format exception. It's the same.
Another situation we use throw is sometimes the exception happens at a lower class, and we don't want to print it out now. We could use the throw. Then it will be transferred to the upper level method, like here, the user interface. Then when it shows here, then it can be traced back to the original class where it first happens. So you will have this whole stack the whole record of the exception, or where it first happens, and then the later method that calls that class. Okay, so these are two situations we often use we use the throw.
The last thing I want to talk about is creating a custom exception. So we could create a custom exception by inheriting from the system exception class. So this custom exception will be an exception, but it could have its own definition of the members, like message or stack trace, by overriding the members in the parent class. For example, here I want to have a statement to check the number of digits of the customer ID is 5 digits, and if it's not 5 digits, it will throw an exception called number range. Okay, number range exception. So what we could do here is to create a new class. This class will be called number range exception. And this class will inherit from an exception I already indicated us.
So next we could add constructors, but you don't have to. And the parent class provides us 3 constructors. One is the constructor with no parameters, and the second one is the constructor with the message. Here, like this one. We created a new instance with the message as its parameter. And the third one is called message, and then exception inner message. So it will be like this. And the next one is the exception. Okay, so this is the third constructor the parent class provided, but you don't have to add them. And more often what we do is to override its members, like the message or stack trace and help link. So we could define our own method here to override the method in the parent. For example, I want to override the message function, so I could write override. It already get us some clues. So I could change this gate. So this gate we could return message called this number should be 5 digits. To 9. Okay. Okay. So yeah, if we call the message, then it will return this information. So let's try it here. Okay, I'll delete this part first because it contradicts to each other. So delete this and let's run to see if it returns us the message. So I'll input 1, 2, 3. And yeah, it did prompt us the number should be 5 digits in this format. So that's how we create a custom user-defined exception. I want you to think about what else we can do to this child class. The child class, you could add your own members, method, or properties, right? So this new object could have some other properties and methods you want to add. So I'll leave this part to you. Last, I want to summarize some best practices for exception handling. Most of them we already demonstrated. First, use a final block to close or clean up dependent resources if there's any, such as a database or files. And second, catch a specific exception and handle it properly, because the more specific the exception is, and the easier the user know how to deal with it. And you could use multiple catch blocks if needed. And third, you could create your own exceptions and use them. Fourth one is handle exceptions as soon as you were informed of it, and they should be handled appropriately. And last, the exception message should be very clear, so the users would know what they need to, how they could meet your requirements of your application, right? That concludes our lesson today. And if you have any question about the content from this tutorial or about the assignment, just let me know.